Aerospace is arguably the most exciting industry in the world today. It operates at the leading edge of technology. A technology to be found in the latest generation of engines, to power civil and military aircraft through the skies at awesome speeds. And in tiny wafers of silicon, dwarfed by a 50p piece, but destined to be tomorrow's gyroscopes. A technology which can predict ground levels ahead of the low-flying jet and warn the pilot to climb quickly, or else. It's all pretty heady stuff, which brings us to the latest generation of helmets for the fighter pilot, with a headset that warns of imminent danger.
Hydraulic failure, hydraulic failure.
And goggles, which superimpose on the pilot's vision essential data for flying the aircraft. That's just a glimpse of what the next few minutes have in store. So, fasten your seatbelts, because this is truly the technology of the new millennium. To keep pace with these fast-moving developments, the aerospace industry needs bright, highly motivated young people. People like Marcel Reed, working on that revolutionary ground proximity warning system. Sally Hunter, designing software to allow pilots to manipulate digital maps. Mandish Panasar, integrating hardware and software for flight control equipment on civil and military aircraft. Morag Howard and Simon Winfield, working on making the famous Rolls-Royce engine even better. Gary Andrews, handing out harsh treatment to a black box flight recorder. Adam Chbosky, learning to set up and operate the latest in computer-controlled lathes. James Allibone, developing that miniature gyroscope, just 10 millimeters across. Stuart McCormick, enabling the jet fighter pilot to talk to his aircraft.
Select ready. Matt.
Mark Chamberlain is heading a project for Eurofighter, involving the management of people and money. And talking of money, Michelle Raven prepares contract bids worth millions of pounds. Because the UK aerospace industry is big business, very big business. Anybody who doubts that only has to drop in on the Farnborough Air Show, the world's premier shop window, organised by the Society of British Aerospace Companies.
It is the shop window not only for the UK industry, but for the international aerospace industry. There are really only two events in the world that can be said to be international, fully international air shows, where all of industry will turn up, and one of those is Farnborough every other year.
There's no denying it's an exciting and dynamic industry. And it's an industry where the technology is having to move as fast as the aircraft themselves. And the speed of that technological development is entirely dependent upon the quality of the people who work in the aerospace industry. Low-level flying has always been a hazardous business. It enables a pilot to fly undetected by enemy radar. But there is no margin for error if suddenly confronted with a rise in the ground. The answer lies in a ground proximity warning system called TERPROM.
Say we're going to be flying a fighter aircraft. We want to stay at about 200 feet above the ground. We'd set a 200 feet limit on our ground proximity warning system, and we'll try and fly the plane at that height. TERPROM will actually give us a little box on the display to tell us how to adjust our flight as we're going to stay at 200 feet, knowing what the terrain is going to be in the next few miles or so. If we go below that 200 feet and we're heading towards the ground, it'll give us a big X on the screen, and you'll actually hear a warning, an audible warning.
Marcel's role in the TERPROM project has been to develop this virtual reality demonstrator to help potential customers understand how the system works in practice. He decided on Aerospace after a year's work experience with his present company, who also sponsored him through his degree in electrical and electronic engineering. And he finds it a pretty exciting place to be.
Very exciting, yeah, yes. The technologies at the moment, especially in the software, are developing constantly. And yeah, it is a very exciting area to be in, yeah.
Navigating, especially over hostile territory, has always added an extra burden to the pilot's task of flying an aircraft. Until now, that is. Sally Hunter is using the skills learned during her Higher National Diploma in Computer Studies to develop a package which is changing all that.
Essentially, instead of the pilot having to take maps with him, having to calculate ranges and so on himself, having to work his way through data that's on the map and obviously permanently imposed on the paper map, we can give him a digital map from which he has every control that he has requested through our customer. He can look at any area, anywhere, whether he's flying over that area or not. He can look at his own data which he's added to the map. He can declutter out data which he's not interested in. For any reconnaissance or anything, he can actually zoom on any area, he can find anything that he wants without having to sheaf through paper or have a navigator go through everything with him. Both channels now are moving. This one here is moving and rotating. This circle here is tracking an item such as a boat or another helicopter which the pilot would be wanting to keep an eye on, either within his own team or as an object for attack.
Sally's work is concerned with this communications module, the operating interface, and the database control module, which extracts the data and displays it on the VDUs. From the day Mandish Panesar joined GEC Marconi Avionics as a software engineer, he has been applying his master's degree in electronics to the integration of hardware and software for flight control systems, a job which has a special appeal.
There's something about writing software for a 500-seater jet that appeals a lot more compared to, say, writing software for a bank auditing system. There's something exciting about it, and that appealed to me a great deal, really.
With developments in aerospace technology continuing at a breathtaking pace, Mandish sees a fascinating future ahead for the software engineer.
We've seen changes in fly-by-wire. We're going to see changes in optic fibres being used in aircraft now. That's going to affect us as software engineers. We're going to have more data, more information. We'll be able to actually fly the plane more accurately. I mean, I almost see a future whereby the idea of autopilot is autopilot. You'll be able to pick up so much information from an aircraft that an aircraft will take off itself. You won't need a pilot to take it off.
The name Rolls-Royce is known the world over, not only for that famous car, but for generations of pedigree aircraft engines. Engines including the Merlin, which powered the legendary Second World War Spitfire, and continuing to the present day with the Trent series, fitted to many of the top civil aircraft. It's on the development of this engine series that these two recently emerged graduates are working.
I'm working on a low-speed fan blade. The main driving force behind this is to try and improve the efficiency levels of the fan and to reduce noise levels. This is becoming increasingly important in order that Rolls-Royce engines meet the stringent noise regulations that are imposed at today's airports. It's not just a case of reducing the speed of the fan though, because the fan still has to achieve all the aerodynamic performance that's required of it.
This is Morag's first real project after completing her graduate training. But her work could have a significant impact on the next generation of Rolls-Royce engines and those people living close to airports around the country. Attracted to the aerospace industry when she was in the Air Training Corps, she got a first-class honours in aeronautical engineering, picked up a few prizes for her work along the way, and rounded it all off with the Glasgow University Engineer Society Prize.
It's the main engineering prize in the Faculty of Engineering. So this is out of all the aeronautical engineers, but also the mechanicals and the electricals and the ocean engineers and the civil engineers. So I was really pleased.
Simon Winfield's work also concerns the development of aircraft engines. He's a member of a team responsible for assessing new engine concepts, and that assessment plays a vital part in the overall design process.
What we're supplying to an airline is a certain amount of thrust to power the aircraft, and hopefully with as little fuel burn as possible. So in the early design stages, it's very important to make assessments of those kind of factors to make sure that we can meet the market requirements and be competitive.
Simon, who also graduated in aeronautical engineering with the help of sponsorship from Rolls-Royce, has worked on several different engine studies, using computer modelling to assess the characteristics of their components.
Obviously the components have to withstand the extremely high temperatures and pressures that are present in the engine, so the model produces that data for us and can then be used to do the detailed design on the actual components in the engine.
Nick Warrington joined GEC Marconi Avionics with a first degree in cybernetics out of Reading University and a master's in control engineering from Sheffield. He's applying all this learning to the design of mission computers for the modern fighter.
The computer that we're designing at the moment is aiming at integrating the sensors on the aircraft and displaying them on the screens for the pilot. As you can see on the flight page here, we have displayed the horizontal indicator and the heading.
One of the things which often concerns young people looking for a career is the problem of making sure their degree is not wasted. In short, how relevant will those hard years of study at university turn out to be when they begin work?
The degree was extremely relevant. In the first 2 years of my degree, I spent a lot of time on software and electronic systems, which is all applicable here. I spent some time doing control systems and systems integration, and that systems integration is invaluable when you're considering that the computers that we're using are commercial systems that involve setting up and integrating with existing pieces of hardware that have been designed by us or other companies.
When the modern jet fighter is hurtling through the skies around the speed of sound, the pilot needs to be able to absorb and respond to information quickly. Stuart McCormick, a systems engineer with computing devices, is using his degree in electronic systems engineering to develop 2 ways to help the pilot achieve this. Like Nick, he's working on visual information for the pilot, but controlling it by voice input, keeping the pilot's hands and eyes free.
Tap disabled, select recce.
Oxygen low. Oxygen
Stuart
low.
is also
Oxygen
developing an
low.
audible
Oxygen
warning
low.
system for more critical information.
Oxygen low. Oxygen low.
Those warnings are the warnings that are executed when there is a catastrophic failure on the aircraft. Now, only catastrophic warning 1 is actually live on the aircraft, and that indicates that there has been a total hydraulic failure on the aircraft.
Stuart is using a test rig to simulate errors in the aircraft, and the hardwired backup system believes it's receiving them in a real flight and is responding accordingly.
Hydraulic failure. Hydraulic failure. Hydraulic
It's
failure.
not the kind of message any pilot wants to hear coming over the headset, because total failure of the hydraulic system means the aircraft is about to drop like a stone. But Stuart's work could give the pilot those few precious seconds in which to eject and live. James Allibone was sponsored through Cambridge by British Aerospace for his master's degree in engineering. And it was during his university vacations with the company that James came into contact with gyroscopes when he worked on the development of this laser inertia navigation system, or LINS for short, in which lasers are fired in opposite directions around a triangle to meet at a fringe pattern detector. Gyroscopes are essential equipment for any pilot.
Yeah, so he has 3 of them, all in 3 different planes, X, Y, and Z, and he has the accelerometers in 3 different planes, X, Y, and Z. Combining all these inputs together, you know how fast you're accelerating in a particular direction and how fast you're rotating around a particular direction. So by combining all these inputs, he needs nothing else to tell him where he has moved from and to in 3-dimensional space. The LINS navigation unit is fitted on the Hawk aircraft which we make and is also installed on the Merlin aircraft, the helicopter, the new EH-101 helicopter for the Royal Navy.
Now, James is working on a completely new technology, a vibrating structure gyroscope, using the silicon we've come to associate with microchips. It has significant implications for the use of gyroscopes, not only in aircraft, but in cars as well, with benefits in terms of cost and size.
This shows the whole of the silicon resonating ring. You can see it's much the same as our metal vibrating structure gyro. The progression has been to put the spokes on the outside of the ring to allow us to put the large magnet in the middle to develop our drive system. The main advantage with silicon, as you see, we have to use a microscope. This is very small, 10 millimeters from here to here, 1 centimeter, and the ring has a diameter of 6 millimeters.
The aerospace industry offers a wide spectrum of careers, not only for young people like James, coming in as graduate entrants, but for those who prefer to come in straight from school through the technician route, like Adam Chabowski. After getting 10 GCSEs, he continued into the 6th form, but decided it wasn't for him. He talked with a careers advisor and went on to a modern apprenticeship with Fairy Hydraulics near Bristol.
I decided I'd rather get some hands-on experience. With going into engineering, I would get the hands-on experience, and I've also been trained up with my ONC and my HNC. An ONC is basically the equivalent of 2 A-levels, and so I've got my A-levels anyway from actually being employed by Fairers.
High-level engineering skills play a vital part in the production of precision components, for which Fairy Hydraulics has a well-established reputation. And Adam is learning how to use a computer numerically controlled lathe to work to those demanding tolerances.
I'm machining a main piston on a CNC lathe. Basically, this is the main part of a tornado tailoron unit. That's the mechanics which move the tailoron on the plane, the flaps up and down. You get a range of work, different components every day. So today I've done about 6 different setups, so 6 different components I've been working with.
When he has got higher national and NVQ level 3 behind him, Adam is looking to obtain a degree through the Open University and feels that decision back in the 6th form was right for him. Gary Andrews, like Adam, chose to come into the industry through the technician route as a school leaver. He gained his higher national on day release and went on to build his modular degree through the Open University to match the needs of his present job as an environmental test engineer. All of the people we have seen so far are striving to develop and build components. Gary, on the other hand, appears to be doing his best to shake this black box flight recorder to bits.
The vibration test is basically trying to life the unit. Anything that's sat in an aircraft or a ship or a car is subject to vibration. Obviously, over a period of time, that vibration will weaken certain components. The idea behind it is that we can simulate years of in-flight service in a matter of days just by using vibration systems.
Here, Gary is subjecting the flight recorder to a shock test, and again, for good reason.
To make sure it survives out in the field. There's no point in having a flight recorder that falls to pieces if you drop it on the floor. Shock testing is, again, trying to simulate in-service conditions. Obviously, with an aircraft, when they come into land, you get a bump or a shock. If something goes wrong with the aircraft, God forbid, and it crash lands, obviously you've got a lot of shocks there as things bounce along the tarmac or hit the side of a mountain or whatever. The shocks it sees are in excess of it's about 60 odd G.
Which is 60 times the force of gravity, and that is some shock. But that's not all this little box has to withstand during Gary's test procedures.
That is armoured steel plate, and the spike has actually gone through it. The black box is actually designed to withstand that sort of force. It's actually the force of that spike is actually in excess of a bullet from a 4.4 Magnum. So it's quite severe. That's to simulate debris flying at the box itself.
There's little doubt that Gary's main focus in life is engineering. Apart from his day job, he spends a lot of time with local schools, encouraging young people with their engineering projects. And his pride and joy is this 1932 Ford, much of which he has hand-built himself. When she left university with a degree in European Business and Technology with French, Michelle Raven set her sights on a marketing role within the aerospace industry. But she was invited to apply for the post of contracts officer with Fairy Hydraulics and agreed. And that job is what she does now, on contracts which are often valued in millions of pounds.
When we receive an invitation to tender from the customer and it's been approved by the board, my responsibility is to look through the terms and conditions and determine the commercial risk for a company throughout the duration of the programme. I then have to flow those risks down to the team members, the bid team members who I work with on the contract, and then those commercial risks are analysed and put into the pricing.
Aerospace is a fiercely competitive industry, and Michelle needs all her business training to play her part in getting that bid right. This contract is to supply the fin actuation system for the next generation of air-to-air missiles. Not only must the contract price be held, but so too must the agreed programme of deadlines.
The time aspect on these contracts is very important. Firstly, when you are putting a proposal together, obviously the customer has a deadline for when he wants the proposal in by. But once you've actually won the business and you've won the contract, you will find that you will be paid according to deadlines. So if you miss a deadline, you won't get paid.
But in spite of all the pressures, when the bid is successful, there's a lot of job satisfaction.
When a contract comes in, there's team celebrations, definitely. It's a very good feeling to get a contract in. You feel as though all that hard work was worth it, and you know that you've won something that's going to have repercussions throughout the company for many years to come.
The Eurofighter has been developed at a cost of billions of pounds as the greatest strike aircraft ever. To work on this aircraft has to be the most exciting project in the aerospace industry. And that is the fortunate lot of project manager Mark Chamberlain.
The actual unit I'm working on is the wing pylon station unit. It's actually part of the armament control system on the aircraft, and it's located on the wings, in the wing pylons, and it's responsible for diverting power signals through to the weapons. So under commands from a pilot, he can actually press his button on his control stick, send signals down to the attack computer and the weapon computer, and that would send further signals down to the station units and send an output power signal which will release the weapon from the aircraft.
Mark got a degree in electronic engineering and joined GEC Marconi Avionics as a development engineer. But he has steadily moved further into the business management side, and his current role of project manager is rather different.
Project management is about managing people and resources. I find that much more interesting because it's totally unpredictable, and it's a greater challenge than actually working on technical problems. Some people enjoy technical problems, the personal side of things. I prefer talking to people and meeting objectives via discussion, negotiation, persuasion, threats, a variety of means. But it's the interaction with people I enjoy more than the cold technology side of it.
So much does Mark enjoy the interaction with people that he's now studying for a Master of Science degree in project management. In fact, Mark is a classic example of using a technical degree as a springboard into more general business management. But David Marshall, Director General of the Society of British Aerospace Companies, sees a wealth of career opportunities for those coming into the industry with non-technical qualifications.
I think the realisation that the disciplines that you can learn from a tertiary university education in business skills that you can bring into a viable industry are hugely valuable to it. I think we're also learning that marketing, for example, is a profession, not just an accident, as it were. And all of those, I think, are producing new opportunities for people to come into the industry who don't necessarily or don't at all start from a technical background. So for someone who comes into this industry, there are huge opportunities in what is an industry not only, I think, at the leading edge from a technological point of view, but actually at the leading edge from a business point of view.
If you think you might like to launch yourself into a career offering these technical and business opportunities, why not find out more? It's an industry based on the technology of the 21st century. And in terms of the future, well, the sky's the limit.